Welcome everyone. I am Vishal Garg here. Welcome to the second webinar at IBEC. Today's webinar topic is Role of Building Energy Code in Creating a Sustainable Built Environment, and it will be presented by Dr. Satish Kumar. Dr. Satish Kumar is Energy Efficiency Ambassador and Vice President at Schneider Electric India. His work focuses on making building energy case for energy efficiency and energy management through collaboration with government. In his more than 20 years of professional career, he has set new benchmarks for bilateral technical assistance program under the USAID Bilateral ECO3 project, worked as a scientist at US Department of Energy's Lawrence Berkeley National Laboratory, and co-founded and served on boards of many non-profit organizations in US, Europe, and India. He has a Bachelor of Architecture from IIT Roorkee and a PhD in Building Performance and Diagnostics from Carnegie Mellon University. I thank him for accepting to deliver this webinar, and now I invite him to start the webinar. Passing on the presentation to Dr. Satish.
Hear me? Good afternoon, everybody.
Yeah, Dr. Satish, we can hear you.
Good afternoon, everybody. Thank you, Vishal. Okay, thank you, Vishal, for the introduction. What I'm going to do is I'm going to be speaking for about next maybe 15 minutes, 15 to 20 minutes. And I am going to be using a presentation. So let me just start this presentation. I think this presentation is a little different than the normal presentation that I make on ECBC. And what I would like to do is to address, I think, all the distinguished people who are listening to this webinar, and start to plant some seeds or some ideas to talk about the overall sort of approach to building energy efficiency. Of course, ECBC is extremely important. I will have some slides, but I would not like to go into the like a lot of detail of ECBC. There is a lot of material that is available. But how do we design an ecosystem? How do we design an overall sort of like, what should I say, the community of practitioners and people who can start to provide, I think, these services to people who really need is what my goal would be. And so I will start with a sort of a high overview kind of a slide, which is on why are we all sort of talking about ECBC or building energy efficiency and everything. So there is the slide that is there by International Energy Agency, and which we have adapted for the Indian context. And so for instance, if we look at what kind of energy demands are going to be needed for India, we are really looking at a fourfold increase in our energy demand as according to Planning Commission projections. And if we start to look at some of these things in terms of how the electricity tariff increase has been happening year over year, so there are some numbers on the left-hand side in terms of what the states have been experiencing, what is the implication on CO2 emissions and other things, so we can see that. And then also, I think one of the other things is that India has traditionally suffered from an electricity shortage, both at least on the peak shortage as well as energy shortage, which is again reflected there. And the point is that all the work that we do, it has to have a context and it needs to have an impact. And I think all of us want to work in areas and fields where we can create an impact, our work can get noticed. And I think that's one of the reasons why I want to put this slide, so that I think if anything that we work either in the area of building energy efficiency or more specifically in the ECBC, needs to have a context. And I think this is the context that we are looking at in the Indian scenario. Of course, it has a global context as well. One data point that I want to talk about sometimes, and people may have heard it, is that if we look at what we need in terms of the requirement that India will have, which is about 800 gigawatt, and what we have currently, which is about 200 gigawatt, we are really talking about, from a generation or supply side, we are planning to bring on board about 600 megawatt of a power plant every week for the next 20 years. So what we mean is that India needs to build a 600 megawatt power plant every week for the next 20 years. And you have to understand the significance of that in order to realize like what kind of a challenge that India faces. And then what can we do to offset some of the requirements, and to do, I think, something that will not tie in or sort of lock us in a scenario where we are stuck with energy inefficient infrastructure. And that's something that is very important to understand. So energy is expensive, carbon intensive, scarce. We are looking at 12% average tariff increase since 2012 in India, 7% growth, annual growth in carbon emissions, 10% average peak deficit, if I want to summarize this slide. The other thing is that we talk about energy efficiency. It's an absolute no-brainer. And I think the challenge that we face in energy efficiency is not that anyone will oppose the idea of energy efficiency. That's not even, I think, remotely possible. Everyone says that we want to do energy efficiency. The challenge that we face is that the impact that energy efficiency can make at a national level, at an organization level, is that something that will entice people to take some action. So this is again a slide that we show that if we want to take energy efficiency, and if we want to say that what is the impact of energy efficiency in terms of 1 kilowatt hour reduction by buying an energy efficient equipment or going through ECBC, what is that on the total sort of like national sort of like impact that it will have, either in terms of the total generation or the amount of coal that we will be importing or the natural gas that we will be importing to drive our power generation plant. So what we are looking at is that 1 unit of energy saved at end user level, and when we are talking about a building sector, we are always talking at the end user level, that will translate into 4.2 units of saved at the power plant level. And that's a fairly important thing to remember in the overall context of things, because that's something that is not understood. And when we are talking about this, then all the things in terms of transmission and distribution infrastructure, in terms of pollution that any power plant will cause or not cause if it is sort of renewable energy, all that is offset as a result of this reduction or the negawatt that we are producing as a result of energy efficiency. So this is something that is important for policy makers and people, that why is this important. So I'm using a slide that is that we have used when we were working for Bureau of Energy Efficiency, when the estimate in terms of the total energy consumption that is going to be there in the building sector, how does it compare as compared to today, and then how does it compare as compared to like what will be the infrastructure in 2030. And this is essentially what we are talking about, is that if we look at the total floor area, we are talking about a 3-fold increase in commercial building sector. We are talking about a 5-fold increase when we are talking about the residential building sector. And I would like to actually draw people's attention to that big sort of like impact area where there is very little work that is being done. I mean, a lot of the work that we talk about is happening in commercial building sector. There are some programs and initiatives that we are starting to show in the residential building sector. But I think we are talking about a 3-fold increase in the total floor space that will be available in commercial building space, and we are talking about a 5-fold increase in the residential floor space that will be available in 2030. So as a result, I think when the policy debate was happening, and when you talk to, I think, people coming from Europe or US, everybody says that, well, the biggest savings opportunity is actually in the existing building sector. We want to do deep retrofits. We want to have ESCOs who can actually implement these programs, and most of the government policies need to focus on really improving the energy efficiency in the existing building stock. They talk about 80% efficiency improvement in existing building stock, which in my opinion is extremely ambitious, but that's what they say, that if we really want to increase the efficiency of the overall building sector, then the focus needs to be on the existing building stock. The situation is very different in India, where we are building at a breakneck speed, which is again I think something that we need to consider, because once that building stock is there, we really can't change anything. So that important point needs to be noted, but it also means that the ECBC execution or the ECBC compliance becomes a very important thing. And if 80% or 90% of the buildings, commercial buildings, are not being compliant at this point of time, and if like 60% are not going to be compliant, say like 3 years from now on, all this existing building stock that is getting built is most likely going to be very inefficient. So it's very important to look at those larger issues and say that what can we do to sort of make the penetration rate of ECBC higher, and how can we actually go about doing that. So I think I am again going to focus more on the high level topics. So in India, we are talking about that, okay, we need to do work in existing building area. We need to do buildings in the net zero energy building area. We need to work on building labels and other things. But the importance, I think, of energy conservation building code in commercial building floor space is, I still very strongly believe that if I have to pick one policy tool and say that, okay, what do you do? Where do you want to put your maximum resources, which will have the biggest impact? There is no question that ECBC remains, I think, that the most important and effective policy tool. Now, a lot of work has been done in terms of development of ECBC. It can, of course, be improved. But the big challenge that we are facing right now is in the compliance with ECBC and developing the capacity of state-level organizations, so that more and more buildings can come within the purview of ECBC. And whether we are talking about urban and local bodies, whether we are talking about municipal corporations, I think different stakeholders come together to make this compliance stronger, and we can do it at a faster pace. I think that, to me, is the bigger challenge that we are facing about. This is again showing that why should we be really worried about this thing. And this goes back to the first slide that I showed, that if you look at the overall, like over a 5-year term also, this is a slightly older data, but what we see that the average electricity tariff is increasing at a rate of like about 13 to 14% at India level, which means that all the macro sort of indicators, whether we are looking at the average tariff or whether we are talking about a lot of these things, it's very important to design the infrastructure which is energy efficient, so that people can take the benefit of that. We can, of course, talk about the principal agent problem and the split incentive problem, but at a national level, it should be a no-brainer that we should be really talking about the impact that a code like ECBC can have, which can reduce our sort of generation requirement, which can reduce the amount of energy bill that all these commercial buildings will be paying, whoever is the main user, that kind of a thing. So now what I'm talking about is that any kind of a tool or a policy mechanism and these things that we talk about cannot exist in isolation. And I think the important thing that as I said, that I'm not going to be talking per se about like what is the U value of like insulation and other things. What I'm trying to do in this presentation is to put ECBC in a proper context, so that I think people don't get stovepipe and they start to work in silos. And it's important to recognize, I think, the importance of ECBC as a policy tool. As I said, it's the most effective tool, but then what are the linkages with other building energy efficiency activities? What are the gaps that we need to fill out, and how should we go about doing that? And what could be some of the other challenges that we need to overcome? So for instance, I'm talking about that it's very important to understand the importance of doing the right thing in to achieve a total like high building performance. So we start with ECBC. We talk about that it's the starting point. Then you can talk about beating the code with the green building rating thing. So then a program like LEED or GRIHA comes in. Then you can talk about that, okay, I have met with ECBC, I have designed a green building, I have beaten the code by 20% more energy efficient infrastructure. Then the third thing that comes after that is that there is always this issue. There was IGBC conference last week. Many people may have attended that. And we always talk about that, is there a gap between as design, which is called the asset performance, as compared to in-operation performance. And I think a lot of credit needs to go to ASHRAE actually for developing this vocabulary. But what we are talking about, that asset versus operational performance. And it's extremely important because we can design a building thinking that it's going to perform like that, but more and more we find out that there is a big gap between, I think, how the building was designed and how it is operating for a variety of reasons. And we can't go into all these details, but I think a lot of people are aware of that. Then we talk about like, okay, well, how do you benchmark the energy performance of a building and go for a building energy performance label? So it could be B-star level, it could be other thing, which is more on operational performance that we are talking about. Then you can talk about like, okay, when you find out that there are opportunities and you are in the bottom quartile or like the in the last 25% or bottom 10%, then you say that, okay, how do I improve the performance? So you can say that, okay, I want to conduct an energy audit. Then you can do a retrofit, measure and verify, and this whole cycle sort of continue. So I just want to put things in context that ECBC is the starting point in the life of a building, but I think we need to be looking at the overall picture whenever we are talking about this. So, okay. I want to come to this, hold on, I think, no, I'm sorry about this. I think oops, I think I missed a slide here. Anyway, I'm going to verbally speak about that slide. So the thing is here that I want to borrow this thinking from Bill Borders, and Bill Borders is of course somebody who I respect a lot, and he has this three thing, which is be lean. So by be lean, he means that you design the building in the most energy efficient manner possible. So you take help of like building energy code, ECBC, whatever you want have as part of your national code requirement. The second thing that you need to do after you have done the be lean, where you have reduced the load, you have eliminated the wastage, you have done everything. The second part is that you be mean. So when we talk about be mean, then we are talking about that you go with the most energy efficient equipment or system that you can afford. So part of it can come from your building energy code, but if you want to go even beyond that, then you can go for very, very energy efficient, if it's like high performance chiller, or if you want to have T5 lighting as opposed to T8 that you can, you want to go with daylight integration, sort of like sensors and control mechanisms. You can do those kind of things. You want to go with high efficiency UPS system. So you pick the most efficient equipment that you can afford, but you do that after you have designed the building in the most energy optimum manner. So the second, so be lean, be mean, and the third thing is be green. And I think be green is where we start to talk about the renewable energy component. So you have done, I think, the most optimum building energy design. You have selected the most energy efficient requirement, most energy efficient equipment. And then the third thing is that after you have done this, if you still have resources available, then you say that, okay, I'm going to have some on-site generation, or I'll go with like green electricity and I can afford that. So you go with the renewable energy option at that point of time. I think the beauty of this approach is that if you really do it well, and suppose we are talking about, say like we are talking about an EPI of 250 kilowatt hour per square meter kind of a benchmark. So at every level that we are talking about in terms of be lean, so you use the ECBC and you design it in such a way that you go beyond ECBC, you will be able to bring it down if you have certain flexibility at the time of designing in terms of site selection and in terms of orientation of the building. you will be able to do it probably, so instead of 250 kilowatt hour per square meter, you can bring it down to 125 kilowatt hour per square meter. Now, once you have brought it to 125 kilowatt hour per square meter, the second thing that you want to do is you want to get most efficient equipment. So once you do the most efficient equipment, you can again do a 50% reduction. So you can bring it from 125 to say like 60-65 kilowatt hour per square meter. And after you have done that, and then you sort of go and say that, okay, I now want to do some building integrated photovoltaics or rooftop units, or I have campus and I can install photovoltaic, or you can do some other sort of renewable energy, then again you will be able to reduce it by 50% by bringing it from say 60 to 30. So what you have done, that you have started from 250, and through this you have been able to bring it down to 1/8 of the thing that you are talking about. So the important thing here is that you have to do all these three things, and you have to do it in the right way, because what you do a lot of times, many of the customers and other people, they will say that, okay, we want to do something, can I just buy like LED, can I install LED light, or they will say, can I do some photovoltaics. What you are doing through that piecemeal approach is that if you have a building which is say 250 kilowatt hour per square meter, or 100, or say even 200 kilowatt hour, you go with LED, the maximum impact that you will like to have is probably like say 10 to 20 kilowatt hour per square meter reduction. So what you are ending up with is that if the building from a starting point was 200 kilowatt hour, you will be only able to make an impact of about say 10% on top of that. Same thing with renewable energy, you will be. So it's very important that I think we follow this, and that's another reason why I think Building Energy Code, ECBC, something that becomes so important, because it helps to create the awareness. If somebody is starting the journey, then instead of saying that, okay, you start with a net zero energy building or this thing, Building Energy Code is sort of like you walk before you run. So you actually go with, you talk about building envelope, you talk about systems, you talk about, I think, distribution losses or transformers and other things, and solar hot water and other things. And at the end of the day, you are going to actually have a building which is going to be much more efficient than what the person was initially thinking. Now, whether you do that through a building energy simulation approach, or whether you do that just purely through good specification, is something that needs to happen in consultation with the building customer or other thing. But I think it's very important that you walk them through this approach, which is a more systematic approach and which will give the customer the biggest bang for the buck. Now, I'm going to talk about some of the things which is again slightly broader level, but talking about this thing. So employment in building construction and real estate sector in India, what we are looking at, that if we are going to actually have the most impact of ECBC, it's not just the designer, the consultant, and I think all the people who are probably on this call. I think we have a responsibility to start to talk about how buildings are actually getting constructed. And I think we can probably say that we are in this 10% skilled workers, or not 10% skilled workers. We are really into this 3% engineers or architecture category that we belong to. But a building is not designed just by us, I mean, or designed, built, and sort of operated and maintained by just us. I think we are playing a smaller role, and I think it's important that people start to see this sector as an exciting sector, where I think you are doing some work which is not just like you are earning your employment, but we are also sort of helping create a more energy efficient infrastructure. We are creating a much more sort of energy efficient building sector for India. But I think our work will have greater impact if we start to look at, I think, all these things. And here I think we are talking about the employability, we are talking about the salaries that people get, a plumber or an electrician and other things, because a lot of people say that why should I be in the 10% skilled worker category if I am not going to get paid with. So I think this is very, very important that we do not look at any of these issues in isolation, and that's the purpose of this slide. And if I can go a little bit beyond this, which that if we look at the skills gap in the Indian construction industry, and this is all I think related to how we can enhance the impact of a building which is an energy ECBC compliant, and why we continue to struggle when we talk about ECBC compliance, when we talk about the capacity that is there at the state level to actually execute and implement the ECBC that BE has developed. And these are the issues that we are facing, and that's why I think the state organizations have problems finding inspectors or even retraining people who are going to be needed in order to make ECBC compliance a reality. So I know that I think a lot of technical work has been done, but I'm trying to give this presentation by highlighting some of the issues where we are really sort of like facing challenges. And if you look at this particular issue in terms of, so India employs about 3 crores of people in the construction sector. And again, same things, like we are looking at about 85% of the people who are unskilled. We are looking at engineers and architects in terms of like about 800,000 people, large number of people, but given I think the magnitude of challenge that we are facing, is still probably a minuscule amount. And if we look at this particular thing where we are looking at the number of people per architect that different countries have. So you look at, for every 300 people in Japan, there is 1 architect. In India, we are talking about every 13,000 people for which we have 1 architect. So, and still I think people say that, well, architects are not getting paid well, only successful architects who have a flourishing practice who are getting paid well. But why can't some of these architects actually go, and I think some of these people are already employed as part of, so say, PWD and other things. They need to play a much more important role in making ECBC compliant and those kind of things. But this is a larger issue, and I think but very closely related to how do you make a bigger impact through ECBC. So I think that's the reason why I'm showing this thing. This is another thing where we look at how many green building professionals are there. And I think if you look at the total square footage that we are looking at US GBC lead level, we are looking at 1.2 billion square feet number. In India, we are looking at about a 200 million square feet. So about 1/10 the size of the US, this whole green building community. Number of lead AP and professionals, 67,000. That number is staggeringly low if we look at from so we are talking about 1%. Even though we may have 10% green build certified floor space, we are looking at 1% of lead AP professionals in India as compared to this. And then if you look at again that per professional, how much service they are providing. So 1 lead AP is catering to about 28,000 square feet. So that's building 28,000 square feet. Whereas in India, 1 lead associated professional is catering to about 10 times that amount, which is again sort of like 300,000 square feet of a space. So I think these are some of the issues that we need to look at, that why are we struggling? I mean, why are we not able to make building energy efficiency, ECBC compliance, and sort of execution go on a fast track mode? And I think these are some of the challenges just in terms of the skilled professional that India has access to. And I think these are the things that when we are talking to BEE or Planning Commission, we are trying to highlight that these are the challenges that the country is facing, which translates into a lower adoption rate for ECBC and other things. Because then when we are talking to state government employees and other things, it takes much longer time to actually educate the cadre of people who are going to make the difference actually in terms of ECBC adoption rate and other things. The other thing that I want to talk about is there is this all the people, all of us feel that the work that we are doing is the most important work in the world, and we would like to be acknowledged and everything. So if you look at, I think, the construction sector, we are talking about developers and financiers. So clearly, I mean, they hold the purse strings. Nothing happens without them. We are talking about architect, engineering, consulting community, probably the community that is in the audience on this talk. So we are the ideas people, and we are the technical people. We make the dreams come true and take final shape through our design and other thing. We are talking about policymakers, regulators. So without the codes and standards and the approvals, no projects can proceed. So they are clearly also very, very important. We are talking about technology vendors. I work for Schneider Electric. So a lot of the companies, we tend to believe that without technologies, we would still be living in huts. So clearly, I think the role that we play is also extremely, extremely important. And then we come to the people like building trades and site workers and these kind of people. So we just have to put everything together. Of course, it's the easiest part. And I think, of course, I'm trying to be a little bit cheeky here, but I think a lot of these things at the end of the day come down to how the compliance is happening, how the execution is happening, what is the quality of construction that is happening, and what ails Indian construction sector when we talk about a lot of these things. So that's sort of like something that, again, in the context of not just ECBC, but overall sort of like the building construction sector, and how we can really improve the overall quality, which will not only help ECBC but green buildings, net zero. I think that's the minimum standard that we need to strive toward. The other point that I want to show here is, I hope that, yes, so what we are looking at is the cost of construction in India. And I know that a lot of times the debate actually sort of veers towards that, okay, what is the cost of construction, and why the kind of materials that get specified. I mean, I work at Schneider Electric. A lot of times when we look at that, okay, what are the kind of specifications that are being made in the Indian construction sector? Why do Indian buildings start to degrade so quickly as compared to international quality buildings? In 3, 4, 5 years, you start to see that the infrastructure is really starting to degrade and crumble as compared to, I think, some of the other international buildings where buildings are there for 30, 40 years and they are very, very well maintained. So the costs shown above, I think, on the side are based on, this was an international study which was conducted on building cost, and EC Harris carried out. And they are typical guideline ranges of build cost that a client would expect to pay, and are based on cost per square meter data provided by EC Harris. These are given in US dollar per square meter of numbers. People who work on international projects will immediately see that these are much lower than international standards. And I think the next slide will show that. And figures exclude land cost, professional and legal fees, etc. So we are really talking about the construction cost, what the nuts and bolts, the materials, building materials, the systems, the lighting systems, the HVAC systems, the kind of electrical low voltage final distribution that is happening on electrical infrastructure, the kind of HVAC systems that are getting installed. So people will make a choice that, no, we can't have central air conditioning, or we will have packaged air conditioner versus central air conditioner, and those kind of things. So how does that translate to an overall cost regime that, of course, is going to influence the kind of products that are going to get specified? So this is the other thing, that here what we are looking at is this international benchmarking of construction cost. And I think I don't know how many people are aware, but this was absolute shocking to me when I first found that out. And what we are looking at is 100% line is the red line that is there. So most of the advanced countries that you see are in the 100% range kind of a thing. So UK from 100, depending on the kind of construction that takes place. We look at Japan, which is the most expensive one, but most of them are sort of like starting from 70% to say 130% range. The 2 or 3 sort of like so all these are developed countries. Once we start to look at 3 countries which are kind of developing, I don't know if we can call China still developing, but China clearly I think is still very different, but it is in the sort of like 40 to 50% range. And when we talk about India, we are talking about 20 to 30% of the cost. So how will that impact the quality of construction that we see in India? Clearly, everything that will be there is not going to be up to international standard mark that we are going to talk about. And that will translate into the kind of infrastructure that gets created in India. Now, is there a possibility to offset some of that with maybe better workmanship or better sort of, so a lot of it does get, I think Indian labor cost is cheaper. I think one of the other things that why you see India the way it is that the labor cost of building Indian buildings is much lower than what it is in some of the developed countries. So that plays a pretty significant part. But it is also true that in terms of the overall specification of the material plays an important. So I think this is something that I just want to show, because anytime we talk about green buildings, people immediately talk about cost and other things. So this is important. I also want to talk about the performance aspect related to energy conservation building code, because a lot of debate that is happening internationally is that how do you really ensure the performance of the building that is being designed as per ECBC or building energy code. This is a study again that we did for ECO3, where we started to look at that what is the typical kilowatt hour per square meter for Indian buildings, and why is it important to actually look that, because there is a concept called outcome based code and other thing, or performance based code, where India is also toying with the idea that just getting a prescription based approval is not going to be enough. So you can specify the performance of the equipment and other thing, but you will only get like ECBC certification or something once after a year you say that, okay, my building is actually 20% below what is the normal standard in India. So if it's like 250 kilowatt hour per square meter, then your building needs to be 200 kilowatt hour per square meter below that if you are going to get like an ECBC code compliance. So there are all these kind of ideas and other debates that happen. Nothing is of course final, but this just shows that anything that we do in ECBC ultimately needs to transform into actual performance. I mean, it's the same story just as green building. And if I look at this is coming from a study that LBNL did, where came out with a best practice guide for high performance Indian office building. And same thing, if you look at the first line, annual energy use, you are looking at a standard data of 250 kilowatt hour per square meter per year. But there are buildings in India which are neither zero energy building or other thing, which are also operating at 60 kilowatt hour per square meter per year. So you have a very wide variation in terms of from 250 to 60, almost four-fold variation. And then better practices can easily take you to 150 kilowatt hour per square meter if you have the right architect and consulting team, and if the customer is demanding and is asking the right questions and is putting, I think, his resources to good use. So I think clearly those things are possible as well. And then similarly, in terms of peak energy usage, there is this whole debate that what should be the connected load of an IT infrastructure, and I think a lot of the debate has happened. But again, you see a wide variation from like 90 watt per square meter or say 9 watt per square foot to about 2 watt per square foot, which is sort of like the best practice. So there is again, I think when a Cisco, when a DLF builds a building, or when Hiralal Nandani, I mean, they build a building. So they say that, oh, we have an IT customer and they are not going to walk into our space if we provide anything which has a connected load of 10 or 12 watt per square feet, that kind of a thing. So this is something that again we want to sort of blow this myth that these are myths basically, because if you are designing your infrastructure in an effective way, you are nowhere going to be using that 12 or 10 watt per square feet that is sometimes rotating around in the real estate sector. And then annual energy use per equipment. So the point that I'm trying to make is that I think ECBC is important. I think clearly, I think that's where the biggest bang for the buck that can be made. But we also need to see that any building that is getting designed, what are the metrics, what are the KPIs that we can use, performance indicators, key performance indicators, against which we can hold sort of the designer community, sort of like the facility managers can benchmark their buildings. It's extremely important that we use these kind of metrics to drive. I'm going to conclude, I think, in terms of, but one of the things that I always also talk about, and I think this is something important, that we see some movement happening on commercial buildings floor space. ECBC continues, I think, to be occupying the center of, I think, a lot of the policy debate, a lot of action we start to see in the states and other things, but mostly in terms of, okay, can we get it like a regulatory teeth into this thing, and there has been good progress, I think, in many states and other things. But also, I think, what kind of support we can provide to organizations that are interested in ECBC compliance. So I think that work will continue to happen. I think more work needs to happen in this space than in any other new initiative as far as a new construction, I would say, at the policy level. Then the second thing is which is also something that we need to start to focus on, is the residential energy efficiency sector, because clearly many high-rise residential towers are getting built. Many government sort of like buildings are getting built in low and medium income housing, and there is a big opportunity to come out with standardized building energy design, which may not have a building energy code associated with it, but which can do the job in a 70 to 80% manner on what are the top 10 things that you need to do when you are designing a residential medium rise or residential high rise building. And I think that there is a huge amount of awareness and education that needs to happen, I think at the government level, again at different state level entities, that government entities. So that's a very, very big opportunity. And of course, I'm not advocating about a residential energy code, but clearly I think there is an opportunity for many stakeholders to start to come together and start to make contribution. And residential sector consumes 3x. So I think the data is there on this slide. And why it is very, very important not to ignore the residential sector as well. And for instance, I mean, whenever I'm traveling on Delhi roads, one of the things that I always think of, that CPWD, for instance, has so many prime real estate. So we are talking about RK Puram, we are talking about Lodi Colony. I mean, these are like real prime estate, and the infrastructure that we look at in these government colonies is absolutely atrocious. I mean, buildings are falling apart. I mean, I don't know, I mean, in terms of what the internal living conditions are. But if suppose I think there is a proposal where people say that, okay, we can start to go block by block and say that these, instead of like 3-story houses or these kind of things, you say that we are going to construct like whatever 6-7-story houses. All these houses are going to be much more energy efficient, so that even though they are going from 3-story to 6-story, you say that you cannot consume more energy than what you have been actually consuming. So you can not only solve, I think, a big housing problem, because clearly there will be more residential units that will be available, which is a big problem, I think, for government sector as well. But you will have a much better infrastructure. You will have a much more aesthetically pleasing infrastructure in terms of urban scape and other things. And there will be more construction that can happen, which can actually help the economy. So I think there clearly could be 4 or 5 birds that can be killed with one stone if this kind of a project can happen at Delhi level. And I'm sure that these things can happen in state capitals and other kind of a thing. So I think these are the kind of things that we probably need to be advocating and telling, which will create, I think, a much bigger impact, and which will not only solve an energy problem, but quality of housing problem, and I think lack of housing problem, that kind of a thing. So the other thing that I want to say, that we really need to move beyond pilot projects. I mean, I myself have been part of pilot projects and other things, but it's time that we start to talk about mainstreaming these things, and that's why ECBC again needs to be very, very important. I get sort of like frustrated when say that let's do a pilot ECPC project. I mean, I'm saying that we are way past that stage when we should be talking about pilot projects. And pilot projects, in my opinion, in India have been abused tremendously. I mean, we talk about pilot projects for 10 years, for 15 years. You are sort of like, and even companies like Schneider Electric, I think a lot of the private sector get frustrated when government keeps talking about pilot projects for 5-10 years. We are okay. I mean, the public sector and the private sector needs to work together. But the thing is that we can talk about pilot project when we can talk about light at the end of the tunnel. So you do a pilot project, or you do 2 pilot projects, but that pilot project needs to translate into an average project which is going to be similar to pilot project. And when that doesn't happen, then I think a lot of problems start to arise, because then you start to lose faith, I think, in pilot projects and other things, and they just stop there. I mean, the complete meaning of the pilot projects are lost. And there are many reasons, I think, why pilot projects are needed. You are trying to showcase, I think, some technology demonstration, lots of things. But this is again a cheeky slide in the sense that why, apart from, I think, all the advantages that you have on pilot project, when pilot project actually starts to lose its impact, and why does that happen? So I'm again not going to read these things, because this is something that people can read, but something that we need to keep in mind, that when we talk about pilot project, we need to think about life beyond pilot projects, because otherwise that's not going to help us a lot. So last slide, this is a Rocky Mountain Institute thing, but we need to really emphasize the process and procedures. And I think, in my opinion, there are no shortcuts around these things. I mean, you take shortcuts at your own peril, or I think customers take shortcuts at their own peril. So you start with the need service in mind, not the amount of stuff that is required to provide it, and check your assumptions. I mean, this we are talking about any project that you want to do. Reduce the loads that cause the need of the service first. Use positive means, interactive measures. Do whatever I think you want. Challenge the design team actually to do the creative thinking, to do the innovative thinking right here. You select appropriate system types and design for elegance. Questions, rules of thumb. I mean, rules of thumbs can be absolutely a worst kind of thing that you can imagine. They are extremely good from a consultant perspective, from this thing, because it helps them do projects very quickly. But if I am the owner, and if I am trying to actually be the project manager for a commercial building, I'm going to question every rule of thumb that any consultant is going to come up with, because that's not going to be, I think, give me an exceptional building performance, and that's the purpose of this. So use efficient equipment, and that's the point. I think most people start here. It's very, very important to not underestimate the power of the first 3 points. Look for most efficient technology options available. Of course, the cost will be important here. So look at what is sort of like your budget for these things. But even without looking at the efficient equipment, you can come out much further ahead if you have done the first 3 things. Switch off when not needed. I think controls is extremely important. And I come from a controls company, but I always sort of like say that go for the simplest controls that is going to work. And I think you should challenge companies like Schneider Electric and Johnson Controls, or anybody, I think, who is in the controls business, to actually give them a controls that works, and not like the most sort of like complex and cutting edge controls which people are going to get daunted by, I think, once I think the system is installed. So okay, examine waste streams for use by other systems. So waste heat recovery, I think a lot of these things. Invest your time in designing a system that is going to actually capture some of those things, and that's where you have to go beyond the code, because these are not the things that is going to be covered in code. Account, unless you are talking about a whole building performance approach where you have really good quality, I think, consultants who are talking about these things, and you have not only people who are talking about these things, but then you have service delivery people who are going to execute and make it work the way it is designed. And then count on benefits and cost upstream and downstream, capital and life cycle, and use the right metric. So that's the sort of like thing that I am going to stop. It's a slightly different take on building energy code, but I think we need to keep I think the right kind of metrics and other things if we want to make a bigger impact using the ECBC as the starting point. So I'm going to stop here, and I'm going to maybe hand over the controls back to Vishal or his team to see how we want to proceed from here.
Thank you, Dr. Satish. You need not hand over the controls as of now. We invite questions from the participants, and if there are any questions, the participants can write to us through the questions tab, and those questions will be passed on to Dr. Satish. We are waiting for any questions. If anybody has any questions, you can write the questions by going to the questions tab and the questions would be passed to Dr. Satish for answering. Dr. Satish, you must have got a couple of questions. You can go to view questions.
Yeah, okay, I'm opening it. Hold on. It's not showing properly. Do not display this question now. So I'm trying to.
Should I read out the questions for you?
Okay, ECBC is the, okay, I think one question that I can see is ECBC is the first step. Can you give some approximate percentage of expected ECBC code compliance after 5 years? It's a good question. I think but it's a difficult question to answer. I would say that the journey on ECBC in India, I would think that it was started around 2004-2005. There was ECBC that was developed, and then there were some other tools and other things that were made available. Very difficult to predict. I can only say from examples of some other countries. So for instance, if you look at China, China is a different kind of an animal, but they claim to have compliance with their energy code in the 90+%. I think nowhere in the world that kind of compliance is heard of. The best that you can, if you are going to get more than 50% compliance, that's considered fairly good. I mean, even in US, I would say that at a national level, it's probably like in the 50-60% code compliance level. But there are clearly some states where it is like 70-80%. There are some states where it is 20-30% also. Same thing I would say that in Europe and other things. So you can imagine that in terms of the developed versus developing country debate, the level of compliance is going to be lower, and then the degree or stringency of compliance is another thing where I think any country that is starting on this path is going to struggle in the initial phases. So I think on those both fronts, I would say that if it reaches in 5 years about 25-30% compliance, then that would be a good level of compliance. But provided that the stringency is also there and we are able to do the checks in a proper manner and other things. Because if you say that, well, I have 60-70% compliance, but it's just a paper trail that is getting developed, I would much rather go for that 25-30, where I think there is a higher degree of stringency and check rather than 50-60 just paper based. But I think in reality what will happen, it will be a combination of those two extreme situations. I think that's what I would feel. So that's sort of like my take on that question. Can you give an idea of outcome-based code? So I think outcome-based code is something that is new thinking within the code building energy code development community. And ASHRAE has started to look at it. There is a lot of discussion that is happening in the US in forums like ACEEE and in California, in New York and other states, where they are saying that we are developing codes which are progressively becoming more stringent and stringent. So If you look at ASHRAE's 2004 version, I think 2004 or whatever, so there was a 2007 version, there is a 2010 version. So every subsequent version of building energy code is becoming, say, 20 to 30% more stringent, just in terms of pure specifications. Okay. Now the other question that people are asking, that as the specifications that are included in the code is becoming more stringent, what is the benefit that society at large is deriving as a result of that? Is that 20 or 30% stringency also translating into 30% efficient building stock 3 years or 6 years? And clearly that is not the case, because A, it is only applicable to new construction, but B, also that there is always this gap in terms of like what is the design intent and what is the actual performance. So the outcome-based code is sort of like an approach where policymakers and sort of like think tanks and consultants, everybody is trying to come together and saying that, can we actually enhance the impact of the code in terms of actual impact on the ground, not just in terms of the specification, which is a good starting point. So how do you do that? I think the challenge, I think, in outcome-based code is like, how do you develop a compliance regime that is going to support outcome-based code? Interestingly, a lot of the new countries like India or sort of like say Indonesia or Vietnam, where these building energy codes are just getting developed, they are saying that for us to do a traditional code compliance method is extremely difficult. So we will never be able to have the large number of building inspectors who will be able to do this job in a clean way and do that. And that's not probably the right path to compliance in a large country like India, where capacity is an issue, where awareness is an issue. So they are starting to look at outcome-based code from a completely different perspective. So they are saying that, can there be tools that can actually help us to reach that outcome-based code as a first level of check? And then can we actually marry, say, a building energy labeling program with an ECBC compliance check program to come out with an outcome-based code, where whatever you want to do, whether you want to go with a performance path or a prescriptive path, that's your choice, but you will be tested or you will be challenged to show that what is the actual performance of the building. And I think so that's actually a very interesting concept and a very appealing concept for a lot of policymakers and regulators, because they say that, yes, I mean, ultimately the goal is to move to outcome-based code and to really capture the performance of the buildings where code is being adopted. But it's, I think, the devil is in the details in terms of how to make that happen. But it's a very, very interesting concept that is starting to get, I think, some traction and some bandwidth from some of the thinkers in this area on how you can actually enable this kind of a thing. So that's the question on outcome-based code. Is there something? Hello, sir. Thank you for the wonderful webinar. What are the bases of prescriptive values in ECBC? Are there some studies for the same? So again, I think very, very good question. I will try to answer it in the manner what is my understanding. So anytime a code development work is initiated at a country level, what is it's actually a very, very good question, just to understand that what is the process that is followed and what is the basis and rationale for coming out with this kind of like value. So people will say that, why do you have U values as X and not Y? And why do you have like a solar heat gain coefficient value, or why do you have a COP value for chiller which is say like 6, or which why it is not 5.3 or this kind of a thing? So it's so my understanding is, and I think I have a fairly reasonable understanding on this, is that typically the way it works is what you do, that you start with a survey. Okay, so you start with a survey to find out that what are the typical technologies that are getting used in a country right now. Okay, so you will say that, okay, we will do a survey, we will get an idea in terms of what are the HVAC technologies what are the lighting technologies, what is the level of insulation that is happening, what is what are the transformer rating, what are so you start with building level, questionnaire, you drill deeper, you start to find out what the systems are, what kind of systems are, what are the typical efficiency values for these systems that are there. The next thing that you do, once you have a general idea of like what the status, what the lay of the land is, or what the landscape looks like in terms of the building space, then the second question that I think that the organization that is trying to develop, they are going to ask is that, okay, when I am trying to develop a code, what is the percentage improvement that I want enabled as a result or mandated as a result of the new code that we are going to develop. So they will say that, okay, when we come out with this new building energy code, we are going to actually have a 20 to 40% efficiency improvement at the building level. That's our goal in terms of the efficiency improvement. That's what we are striving towards. So that's a very important exercise where people are, this is not something that can be done in isolation. So there are ECBC committees or building energy code. So different people will provide their viewpoints. Then the third and most important thing is there will be a community of people, say developers or end users, who will say that what is the impact, the economic impact, or improving the level of efficiency that we are talking about. So they will say that, okay, from 250 kilowatt hour per square meter, which is sort of the typical number, if you are saying that you want the buildings to have like come to 200 or 150, then what is the economic impact that the developer community will face, or the customers will face who are going to design the new building? Now, once that kind of a thing has been laid out, then this whole process starts in the sense that, okay, let's go to the HVAC manufacturers, let's go to the lighting manufacturers, let's go to the controls community in terms of what is possible, what is the cost premium that this technology, a particular kind of a technology, will have. So the code development group needs to have access to this kind of information from the different stakeholders who can provide this information. Then there is a group of people who are modeling the different scenarios in terms of that, okay, currently the level of insulation is this much, we want to actually go to this level, currently the COP of chiller or packaged air conditioner, this is this much, we want to go to this level. So then the whole sort of like modeling exercise starts, and they start to talk about, then you start to see that, okay, what is the efficiency impact that is going to come if you start to select the different thresholds for different specifications, whether we are talking about insulation, whether we are talking about luminous efficacy, whatever I think we are talking about. Now the process is that, okay, and then with the data that you have collected on the economic impact, on the costliness of these technology, so the results that you get from these multiple simulation runs in different climates and other things, then you say that, okay, what is the typical increase in the cost of the building that we are going to encounter? So you say that, okay, we want 30% increase in efficiency, but we don't want anything more than 5 to 7% increase in cost. So that government or like the body will need to take a call on, and then they will have discussions with businesses in terms of the energy efficient equipment manufacturer, different technologies, and they will say that, okay, if we actually get this bigger a market and if we have more products, then we will be able to actually contain the cost of these technology to these numbers. So I think, so this is a very, very sort of like, you can understand that if you follow this process in a very sort of like a structured and rigorous manner, then it becomes a pretty complex process, and it has many stakeholders who need to be consulted. And then finally, I think it's decided that, okay, we are going to go for 30% improvement or 20% improvement. This will be the economic impact. This will be the national level energy savings impact. So government will say that for India, we want actually energy savings is a very, very big driver. And even I think if it means that we are not going to just limit to 5-7%, but even it can go to up to 10% increased cost, I think that's okay. So I think that's the kind of process that gets followed, and it is typically followed anytime an energy efficiency standard is being talked about. So even for, say, a chiller performance energy efficiency standard or a lighting energy efficiency standard, it's the process is actually not very, very different. So I'm sorry it was a long explanation, but I think I couldn't answer this problem in a very straightforward way. Any other questions? I don't know if we have any question that I have missed. Okay, so I think is there? Yeah. So Vishal, I'm not sure if there are any other questions. I think I saw 3 questions which I answered.
Yeah, I think there are no more questions. So I'd like to thank Dr. Satish for this wonderful presentation and also for very patient and elaborate answers to the questions that the participants have asked. I also thank all the participants. Still, all the attendees are present and listening, and for making this interactive webinar. We'll be hosting this webinar on the IBEC portal for those who would like to view it again or those who have missed it. I thank you all once again. Thank you, Dr. Satish.
Okay, thanks a lot, Vishal, and thanks for the opportunity. Bye-bye.